Hi. In our previous video, we applied what we learned about second-order differential equation to a price, to a market model with price expectations. Right? So that was microeconomic model. Now we're going to turn to macroeconomic model, and we're going to discuss the interaction between inflation and unemployment, or the Phillips curve that you know from macroeconomics. Of course, I know that you've dealt with this in detail. So here we actually going to be looking at the stability of equilibrium in this model. However, we're going to start from a little bit softer tone, and we're going to set everything up, discuss all the parameters in the context of what was discovered in macroeconomics research. Okay, so Arthur Phillips published a paper in which he demonstrated empirical relationship for the British economy. And in this relationship, we had growth rate of nominal wages, lowercase w here, and unemployment over here. Right? So we had, and he estimated a curve that looked more or less like this. Okay, what was this curve telling us? Basically, it told us that growth rate of nominal wages is some function of unemployment, and that this function has negative first derivative. So the higher the unemployment, the lower the growth of nominal wages. Okay, just to be sure, you will denote unemployment. I just want to also remind you that if we take any variable, let's just say y, and we see dot over this variable, this by definition means that this is time derivative of this variable. Okay, so what w here is, lowercase w, is a growth rate of nominal wage. So here we have time derivative of nominal wage divided by wage. So W is nominal wage. Okay, so how could we explain such a relationship? Well, the first explanation that comes to mind is that with high unemployment, the bargaining power of workers is small, right? Because if they lose a job, they will not be able to find the next one easily. However, the employer can basically cherry pick any employees that he wants. So we would expect that with high unemployment, low bargaining power of workers results in this shape of relationship between growth rate of nominal wage and unemployment. However, a couple of years later, Solow and Samuelson estimated very similar relationship for the United States. However, they changed here one thing. What they put on the vertical axis was inflation. Inflation here we will be denoted by lowercase p, and it is defined as P P with a dot over P, but remember this is capital P, this is capital P, this is lowercase p. So P is the price level, and look, in this context, lowercase p is inflation. Okay, and again, what they got was a very similar relationship, right? So they got a very similar relationship. However, instead of using growth rate of nominal wages, they used inflation. How was that explained? Look, why would the price of a good go up? Look, we clearly see the connection between wage, well, in this case, growth rate of wage, and inflation. Why? Well, look, the stronger, the bigger is the growth of nominal wage, the higher is the cost for employers. The higher is the cost for employers, the higher must be price of the product. Okay, but look, this is not it. For example, what about productivity? Maybe let's note it as growth rate of productivity. How does productivity influence prices? Look, if we have higher productivity, it means that at the same cost, we can produce more. So actually, what we could do is to lower our price. So let's just make this very simple relationship here between inflation, wages, and growth rate of productivity. And we see that the higher the wage, the higher is going to be the price, the higher the cost, the higher the markup. However, the higher is the productivity, the higher is the lower is going to be inflation. Of course, in a special case when they are equal to one another, we should have no inflation. Okay, so now, how can we bring those together? Okay, let's just say that for simplicity, we're not going to be using here nonlinear models. We're going to be using linear models, right? So let's just say that our wage unemployment relationship is simply given by alpha minus beta unemployment. Well, of course, this is lowercase w. This is growth rate of nominal wages. And look, knowing this, of course, assumptions. Alpha and beta are positive parameters. Okay, now, knowing this, why not substitute for wage over here? And then, what are we going to get? Well, we're going to get that price level, inflation is equal to some parameter alpha minus t minus beta unemployment. And look, what we see over here is a simplified version of so-called old Phillips curve. Okay, what is the logic behind this relationship? Okay, look, if prices are going up, it means that other things being equal. Now, right? If price is going up, and let's just say that wage stays the same. What does it imply for the employer? Look, you are able to sell your product at a higher price, and at the same moment, you're paying your employees exactly the same amount. This means that in real terms, your cost of production has declined, right? If your cost of production is declining, you will produce more. You will hire more people, unemployment will go down. And look, that was the entire idea behind that old Phillips curve. Assuming constant nominal wages, we would, or constant growth of nominal wage, we would see that higher the price level, the lower is the real wage of the worker. So the lower is the cost of production for the company, the more company can hire, the lower is the unemployment in the country. Okay, but as you also probably learned in macroeconomics class, this relationship was not holding very well over a longer period of time. What happened? Well, it turns out that this relationship held the way it held for a very simple reason. Look, in the period when Phillips' relation was estimated, we had once inflation, once deflation. It was averaging out in zero. However, with modern tools of monetary policy and with different approach to inflation, everything changed. Because look, now, if we had a situation that we have 2 years of inflation, 2 years of deflation, 2 years of inflation, 2 years of deflation, then what you expect from the worker is that this will not have big impact on their decision on wage bargaining, asking for higher wage. However, if there is inflation year after year after year, it means that the real wage of the worker is going smaller and smaller and smaller. So, if worker expects the inflation to happen next year, the worker should demand for higher wage, nominal wage, to compensate for this increase in price level. And this actually led to creation by Friedman and Phillips independently at the same time, basically, something that we call now the expectation, oh, maybe I'm going to write it with color, the expectations augmented Phillips curve. Phillips relation. Because this is how it's in your book, so let's keep it. Okay, so what was the big revolution over here? Look, basically, what we do here now is that when we have equation for growth rate of nominal wages, we need to include in it, except for the unemployment, we also need to take into consideration lowercase pi, which is expected inflation. With of course some parameter in front of it. This is parameter g. This parameter g is somewhere, let's just say between 0 and 1, where 0 actually moves us back to the old Phillips curve. So look, what is the big difference? What is the big deal? Look, now it turns out that we have actually a family of Phillips curves. If, for example, let's just say that this Phillips curve is associated with expected inflation of 0, then what will happen if households, workers, start to expect inflation to be 4%? Well, if they expect that inflation is going to be 4%, they should demand higher wages. And this actually produces a new Phillips curve that is higher. And look, why is it higher? Well, now, as workers expect inflation, then they will require higher wage, which means that inflation needs to be even higher if the economy would have to benefit in the form of lower unemployment, in a sense that you would need to have 5, 6, 7% inflation in order for the companies to feel that they actually are benefiting from hiring more people, because they are selling their products at a higher price, and this higher price compensates for increase in wages. So look, that was the revolution, that actually, depending on what workers expect at a given time, we will have a different Phillips curve. We'll have a different. So we actually have like a family of Phillips curves, each one associated with a different expected level of inflation that would in turn influence growth rate of nominal wage. Okay, then right away we see that this is a brilliant idea, right? Of course, we should take into account what people expect in terms of inflation, because we cannot cheat them very long in a way that central banks at some point started to using monetary expansion too much in order to lower the unemployment, through higher prices. But at some point, workers can actually see that they are making less in real terms. So even though they make the same or a little bit more in nominal terms, they can buy less with the same money. Okay, so this idea was very fundamental, and it actually changed the way countries started conducting monetary policy. But here appeared a second issue. Okay, so we know we should include expectations in our models. However, how should we do it? And I'm actually going to start from the present, and I'm going to go back to the past. Look, the consensus now in macroeconomics is that we use rational expectations hypothesis. What does it mean, rational expectations? Rational expectations means that economic agents use information available to them effectively in making their predictions about the future. Does it mean they are always right? No, of course not. Look, if the best economists and statisticians in the world cannot make really good predictions, how could regular people? The key in understanding the rational expectations is that people generally use the information to make as accurate predictions as they can. Now, this has a lot of hidden assumptions and actually problems associated with it. However, what this fundamentally implies is that generally, if central bank, for example, says that we are going to meet our inflation target, and our inflation target is going to be 2%, then let's just say the first year, workers trust the central bank, and they actually make the wage bargaining on the assumption that inflation is going to be 2%. But the central bank cheated and actually allowed inflation to be 5%. Next year, if central bank is going to announce that inflation is going to be 2%, our economic agents are not that naive. They're going to learn from their mistake, and they're not going to trust central bank, and they're going to assume higher inflation. And actually, this brings us to our second point. When we model rational expectations, we actually are assuming that those expectations are compatible with the model. What does it mean? If the worker knows that central bank can benefit from cheating the worker and telling him inflation is going to be 2%, while in fact it's going to be 5 or 10, then the worker will take this into consideration. The worker can make the mistake maybe the first time, but it's not going to make the same mistake twice. And this is what we are assuming, that the worker is going to take into consideration the possibility that the government or central bank in this case can cheat in a way that promises something, delivers something different, because we've got a goal of lowering the unemployment. Okay, of course you can say that, but this is very irrational. Like, I don't even know what is level of inflation in Poland. The level of inflation in Poland is low, and in most of the countries it's very low. And look, because of that, the cost of obtaining information about inflation is very high in comparison with benefit. So when you have relatively low inflation, you do not look up for this information. However, look, imagine that inflation in your country or in Poland is, I don't know, 20% a year. So when you actually go to store, you see the prices are changing. It affects you in a meaningful way. So in this case, you would be more than willing to actually try to look for the information, right? Okay, but we are getting off topic. So basically, in the modern literature, we usually use this, we use rational expectations in a sense that those are the expectations that are compatible with the model we are using. In our model, there is a central bank has an incentive, right, to increase inflation to lower the unemployment. And with rational expectations, the economic agents take this into consideration. And look, this type of rational expectations in models are very often very complicated to explain. However, we are going to use them in international economics class, especially when we're going to discuss Dornbusch model. Then we're probably going to start in here, but we're going to definitely finish it in international economics class. Okay, so we are actually not going to do rational expectations over here. We're going to start with something a little bit simpler that actually works very, very well. And this is called adaptive expectations. Okay. Okay, so what does those adaptive expectations mean? Look, let's just say that this derivative, d pi dt. So, first derivative of expected inflation is given by following expression. J times P minus pi, with J of course being bigger, with J being bigger, actually not only bigger than 0, but J being between 0 and 1. Okay, what do we see over here? Look, what is this difference that you see over here? This is actual inflation, and this is expected inflation. So what we have inside the parenthesis is the error, let's just say workers or agents maybe. Error. Okay, what does this error imply? Look, if inflation is bigger than expected inflation, this expression is positive. If the otherwise, it is negative. And look, we see because J is somewhere between 0 and 1 is definitely positive, it means that every time when actual inflation is bigger than the expected inflation, economic agents adjust their expectations upwards. And look, this is something that is also very intuitively understandable. In what sense? Look, if you expected that central bank is going to keep inflation at 2%, but it was 5%, next year you will adjust your expectations upward, right? You would expect inflation to be 4, maybe 3, maybe 5, maybe 6%, right? However, in this context, we are assuming that only part of this, you see, in the worst case scenario, like with J, let's just say one worst, maybe best, well, you cannot put actually normative opinion about the value of a parameter. But however, in the corner case, the entire error is translated into the correction for this error. So what we see, that adaptive expectations are telling us that every time when we make a mistake, we are trying to account for it in the next period. So if inflation that was expected was 2%, but actually was 6%, right? We expect that the workers, economic agents, will expect that next period inflation will be higher, and as a result, expect that inflation is going up. Okay, so look, what do we have? What do we have over here? We have the relationship between wages and unemployment, right? But we simplify it. Then we simplified it to. Then we simplified to a wage we first simplified it into linear form, and then we substituted it into the price relationship for inflation. We got it over here. So look, what can we write down is that we've got that price is equal to alpha minus t minus beta u, and we account, of course, also for expectations. Then we got the second equation that is telling us how expectations are formed, right? This is this d pi d equals j times b minus pi. Okay, so what are we missing? Look, well, we do not know what is the feedback from inflation to unemployment. We were saying that I was constantly saying that central bank can do this, central bank can do that, but basically all that I was saying was that central bank can influence inflation. So now let's go to the feedback from inflation to unemployment. Okay, so now the question is, can central bank change unemployment? And of course, I think all of you know from all your macroeconomics classes that it can. How does the central bank does it? Well, central bank uses monetary policy, right? So what central bank can do? Central bank can increase growth of nominal money supply. So our M here is M with the dot divided by M, right? And M is the nominal money supply. But what else do we know from macroeconomics? If we want to impact the economy, we would like to increase real money supply. And real money supply will be given by this. Well, technically speaking, what we have over here is the growth rate. Because look, this is growth rate of money supply. This is growth rate of prices, so inflation. And we know that M minus P is the growth rate of M divided by P, right? So what we see over here is a growth rate of real money supply. Okay, and of course, we need to default some parameter as usual, of course with a minus because we're going to assume that k is positive. Okay, and now we've got the complete model. Let me just put it down because this is going to be the model that we're going to solve in the next video. Okay, so what do we actually have inside this model? So first, we've got expectations augmented Phillips curve. So we've got P equals to some parameter alpha minus T minus beta U plus G times expected inflation, and we are assuming, of course, that parameters alpha and beta are positive, while G is somewhere between 0 and 1. Okay, then the second equation constituting the model is going to be the equation telling us what is how expectations about inflations are formed. So this is J times P minus pi, where J is a number between 0 and 1. Okay, and finally, we just got the last one, so the feedback from inflation to unemployment. We've got that this is the change in unemployment is proportional to the growth rate of real money supply, with K being positive. Okay, so these three equations constitute a full model. However, when you look at them, you might notice one very simple thing. Okay, but where is the second order differential equation with constant coefficient and constant term? Well, what can I tell you? It is somewhere. But we cannot get it just by looking at it. We will have to work a little bit. Because look, what we are going to do in the next video is that we're going to find the time path of expected inflation. You're going to do probably unemployment or inflation with Valeria doing the workshops. So, what we need to do is to use those three equations, all of them, put them into one equation and differentiate and rewrite different things in such a way that we will get into one second order differential equation. And of course, at the first time you do it, it's very troublesome. Yeah, but once you know a couple of tricks, it's very easy. And then, as you will see, the solution, once we've got the equation, is just trivial. But of course, this is going to be the topic of our next video. So thank you for your attention. Take care.